In an era where data is the new oil, machine learning algorithms are the engines that drive modern innovation. They are the silent wizards powering everything from your personalized Netflix recommendations to the intelligent systems that predict stock market trends. Two of these algorithms, regression analysis and classification, are like the yin and yang of machine learning. Today we dive into the heart of these two, comparing, contrasting, and understanding their unique strengths and limitations. Imagine regression analysis as a skilled archer. The goal: accurately hit the target. It is a predictive modeling technique that estimates the relationship between a dependent variable, the target, and one or more independent variables, the arrows. It is all about forecasting continuous outcomes. Think along the lines of predicting house prices based on factors like location, size, and age. Now consider classification. Think of it as a discerning botanist, categorizing different species of plants. It's a technique for determining which category an observation belongs to, based on a training set of data containing instances whose category membership is known. It's about predicting discrete outcomes. Picture a spam filter that categorizes emails as spam or not spam based on content, sender, and other features. While both regression and classification are supervised learning methods, meaning they learn from a labeled data set, their application and output type set them apart. Regression deals with real numbers and continuous data, like predicting a house's price or a student's test score. Classification, on the other hand, deals with discrete values and categorical data, like identifying if a tumor is malignant or benign, or if a transaction is fraudulent or legitimate. Regression analysis, like our archer, can sometimes miss the target. It assumes a linear relationship between variables, which is not always the case in real-world scenarios. It's also sensitive to outliers, meaning a single extreme data point can significantly skew the results. Classification, like our botanists, may sometimes mislabel a species. It often requires more computational resources, especially with large data sets. It can also struggle with imbalanced data sets, where one category greatly outnumbers others, leading to less reliable predictions for the minority class. Yet, despite their limitations, both regression analysis and classification hold their ground as invaluable tools in the world of machine learning. They serve different purposes and are suited to different types of problems, but together they form a dynamic duo, helping data scientists decipher the stories hidden in the vast seas of data. In a nutshell, regression analysis and classification are two sides of the same coin. They are both powerful, flexible, and fundamental to machine learning. They differ in their goals, their output types, and their limitations. But at the end of the day, they are both striving to make sense of the world's data, one algorithm at a time. Such is the epic battle of machine learning algorithms, regression analysis versus classification. It's not about which one is better, but rather which one is better suited for the task at hand. And in this data-driven world, they both have crucial roles to play. Like the yin and yang, they are different, yet interconnected, each complementing the other in the grand scheme of data science. And so, the battle continues. As data grows and evolves, so too will these algorithms, adapting and learning, forever striving to make sense of the world around us.